Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking at a distribution called NixOS, a very unique distribution. Stay tuned right after this. We'll talk about it. So, yeah, the version I'm going to be looking at is 21.11. I thought I saw 22.05. It should be out soon. I could have sworn I saw it out there, but maybe it was just the beta. But anyway, 22.11 is the most current as of the time I'm making this video. But I've been getting a lot of requests from people to, hey, could you look at NixOS? And so, all right, let's take a look at it and see what makes it unique. So I think I'm going to start with the problem statement because this distribution is very unique and it has an approach to a particular type of problem that we have been encountering pretty regularly in the Linux side of things, particularly in cloud environments, in machine room environments for probably the last 30 years. There are two programming models that you can use to solve problems. The most common one is the imperative model. And the Linux distributions that are out there, like the common ones like Fedora and Ubuntu and Alpine and Debian, they're all imperative. So what the heck is that? What does that even mean? So imperative means that you go about solving a problem by specifying all the steps that you need in order to reach the final state or the solution that you're looking to be able to provide. So further, each step that you take changes the state because you need to know what steps have been done and what steps are needed to be completed in order to get to the final state. I guess the thing that we should do is we should look at kind of an example. And we'll talk about some of the pitfalls that the imperative systems have when trying to do things. So I might have a vision of how I want the final system to look. I mean, it might be that each system type, that is, if I'm designing a system type that's an edge server, for example, or it is a cloud server, those are going to have a different characteristic build out that are different from, say, one that's going to be running Nginx or an Apache web server, maybe a database engine or an analytical engine that would be out there that's collecting data, or maybe one that's running artificial intelligence, machine learning. So yeah, I mean, those are going to all be different, and how to manage all of those in an imperative system it's not straightforward, because I have to morph the base system that comes on the ISO into what I want as the final state for the system. So let me give you an example. Let's take a real simple example. Let's say that I'm trying to get across town to an address. So in an imperative system, I would put in the starting address and the ending address, and the imperative system would figure out all the turns that were needed and the directions that were needed to get me from where I am to where I need to be. And it may even quote times if it knows that I'm traveling by car or if I'm walking or using a bicycle. So yeah, I mean, it could even tell you that. That's how long it's going to take to get to the final destination. The problem is with systems like that, when you're dealing with packages, is I don't know how many times we have written up installation guides for a particular type of machine. Now, the last major system I had a total of 3 enclaves, and each of those enclaves had 18 different types of systems. There was also a front end. One of the enclaves was like a front end, which is where all the stuff was gathered, and then it was distributed to a high and a low side. Yeah, I don't know how many times we would build out these manuals, and we would build up the system because maybe we're updating it, or maybe because we were changing out hardware. But I don't know how many times we would perform these steps, and we would always have some kind of failure, that this did not install successfully. It didn't work successfully. So what's up with that? Well, the problem is that we're human. When people are writing up manuals, a lot of times, I mean, they're carrying around all these steps in their head, and they may not write it down because they've done it so many times. It's muscle memory, and they just forget to write down this step that they know that if they were performing the task that they would do. And that happens with these kinds of things. It's not something that you want to happen, but it does happen. The other problem that you might run into is that over time, as a system matures, there may be updates that are coming for the packages that you're building out your base for. And those can alter the order in which those packages are installed, because you may have additional dependencies that a new version of the package has that need to be done first, or it may be overlaying older versions of the software that you don't want overlaid. So sometimes older or newer packages can create havoc as well. They can taint the operating environment and cause application failures, or at the worst case, they can also prevent the machine from booting. So because of a library mismatch or a code mismatch. There are solutions to all of these problems, but every single one of them doesn't make it more easier. In fact, they add additional packages to make it more complex. So a lot of times, instead of making a simple solution easy to solve, they complicate the solution by adding all this additional things that need to be on, or they may create a new machine type that now you have to support in addition to the ones that you were having to support as well. The other problem that you have with those kinds of systems, with the imperative systems, is it makes it difficult to be able to cookie cutter those machines onto other machines. Okay, so yeah, you could create a VM and you could snapshot it, and then you could create as many copies of that snapshot as you want. But what happens if that snapshot gets old? I mean, what if it ages and that's no longer maybe there's vulnerabilities in that snapshot. So now you're going to have to deal with that problem, right? So yeah, over time, those are, it's not that they're causing you additional problems, but again, it's an additional thing you have to maintain. So, and that includes, and the other problem is that the virtual machines and the containers all make the footprint larger, because in a case of a VM, you are replicating additional pieces of the operating system into each VM that you normally wouldn't need to have. Now, that's not a criticism of a virtual machine. That's just a fact. That's just what we have to do with it. Is that a good thing? Well, maybe. But, again, if you're looking at this from a security point of view, each one of those is expanding your surface, your attack surface. So, yeah, it also means that you now have, instead of one machine to maintain, you may have 50 machines to maintain because of the number of virtual machines you've created. Containers do exactly the same thing. They have to be kept updated too. The software that's inside the container has to be updated periodically in order to keep it current and free of security issues or bugs that may cause the application to fail. We don't want that to happen. So the bottom line is, yeah, we have all these things. I mean, you could look at Ansible, you could look at Puppet, you could look at Chef and all those things that you have, but those are just adding on complexity to the system. So, yeah, and none of those are really optimal. They're optimal from a standpoint of something that will scale, and that's the next part of this, is scaling up. So let's say I have thousands of computers that I want to be able to define a particular machine class or machine type, web server, app server, database server, AI server, analytics engine, whatever, that I need to have. Maybe there's some for security, some for user management, some for config management. But each one of those needs to be configured for the type of task that it's going to perform, right? So let's say I scale that up to 1,000 machines. Well, I have to identify how many of each type I'm going to have. I'm going to have to identify all of the different versions of the master configuration for those machines that I want to be able to deploy, so that I'm deploying the same thing to each one. It's very difficult to keep everything in the exact same state. You have to consider everything: hardware drivers, software libraries, supporting libraries, configurations that define what is on the system or how the system is set up and which is turned on and which things aren't. So imagine that you're a Facebook where you're receiving, let's say, 1,000 systems every day, and over time, your configurations are, unless you're building them yourself like they do. But imagine that you were buying a commercial system. Those systems get updated. There's engineering releases to the motherboard. There's engineering releases to the boards that are in place. Sometimes they change out the chipsets that are built up to support your networking cards or your disk channel support. Or even the CPUs can change over time. Maybe the default one had 12 cores, and now the one they're putting in has 24, and it has a different set of features in it as well. So imagine the type of problems that you're going to have if you're receiving these systems a little bit over time, and as the timeline extends out, all of the changes in those configurations that are being done by the manufacturer and how those are going to impact what you need for your server types and how you define them. So I guess you can see that this is quickly becoming quicksand, right? Now we can talk about NixOS and Nix. So there's really two different things here that you can do. So first, NixOS is a distribution that contains their own package manager, Nix. Or you can take an existing distribution, let's say Debian, for example, and I could go out and I can install Nix directly on it. And I can change out the package manager that Debian is using for Nix. Now, why would I want to do that? Well, there's a couple of reasons for that. One, maybe I want the versioning that Nix provides. Second, Nix it's the second largest package repository, second to only Arch, out there. So you have the latest packages, the most up-to-date things that you can get your hands on, and you have this versioning control system that you wouldn't have in maybe your favorite operating system. But you can also do NixOS, where you just replace the operating system altogether and run it. The NixOS comes in several flavors. One is it comes built in with a desktop environment, and the second one, it comes as a minimal, which doesn't include a desktop environment, so then you can build up your servers the way you want them. I believe there is only a 64-bit for the desktop environment, and there's a 32-bit or a 64-bit. Now, these are x86 platforms. I don't believe at this time, I did not see anything for ARM or PowerPC. I didn't see anything like that. So what's the problem statement for NixOS? So NixOS is a declarative system. All right, so now we have imperative. We talked about that. Now we have declarative. What the heck is declarative? So declaratives, they state the end state, the end goal. They just say, let's go back to our address problem. So I want to get from the point A to point B, and the system and a declarative system doesn't do anything other than here's the address for where you want to go. It doesn't specify how to get there. It doesn't do any of that. All it does is says, here's your end state, and that's it. How it manages to get you from where you are to the end state is an implementation detail, and that can be changed on the fly. So there's more flexibility in a declarative system over an imperative, because imperative systems are basically hardwired. You don't have a choice. You have to complete step A before B, and you have to complete those in order. If one of them fails, well, now you got to roll back and start over, right? In a declarative system, you don't care about what it does and how it gets you there. All you want to know is, where do I need to go? So that's the difference between it. So, and NixOS takes this unique approach forward to package management and system configuration too. By the way, there is a configuration file that Nix creates. There's also a hardware configuration file that NixOS creates as well. So you define the system configuration during the definition phase of your system build. So you define what packages I want, what desktop environments I want, what users I want, what networking things I want, what firewalls I want, and what rules I want to have set up for those firewalls, for example. All of those things are done before you begin, and you set those up, and then you start your build through the Nix utilities, and it will construct the system according to your wishes. The other thing is that configuration file remains, and as the configuration files are built, there is a version that's kept on the system and becomes part of your grub order. So you can then have versions that have older things in it. So if the new one doesn't work for some reason, there's a place you can roll back to a known working system. So that allows you to modify the system configurations over time. Nix maintains a generation for each rebuild, so and you can clean those up periodically. There's a garbage collect that you can run that will clean those out for you periodically. The other thing about Nix is it's atomic. So if it's installing a bunch of packages and those packages have in turn dependencies, if the dependencies fail, then Nix will stop, roll that back so that you aren't left in a state where I have half of the packages I need installed and half the packages are still not installed. As you know, that could cause a failure with the application, but it could also potentially cause a failure with booting the system up again. So yeah, any failure will roll the update back. So yeah, packages are immutable, but Nix uses kind of a different way of handling this. Rather than having an immutable file system, they have immutable packages. They permit multiple versions of the packages to be resident on the system at the same time. So yeah, so does this sound like Silverblue? Well, kinda, but it's not. It's a little bit different than Silverblue approaches this problem. So the other part that NixOS does to take a unique approach to this is it builds its packages in isolation from one another. That's how you're able to maintain different versions of the same package on the system. They use, if you'll look at /NixOS directory out attached to your root, you'll find your packages are installed under there with a hash. So each package, every time it's installed or updated, generates a new hash, and so that gives it a unique fingerprint on your system. The other thing is that I can lift my configuration files. I can put it on another system and I can generate the exact same system I just did. So, and that makes it easier for when I want to share my build with environments on other projects. Not so easy to do with a lot of them, right? Unless you want to build up a large number of Ansible scripts to do it. So Nix ensures the installation or upgrading a package will not break another package. That's their goal. Can it happen? Sure. I mean, there's always ways for something to leak through a system and cause a catastrophic failure. So nothing is perfect. Remember, this is written by humans. Let's talk a little bit about the system requirements a little bit. So the recommended desktop is, this is a 64-bit dual-core CPU or more. These are my recommendations. I didn't see anything, but they're probably in their manual someplace. They do have, NixOS has really excellent documentation, and the manuals go into the steps you need to set up, but then they go through all of the individual pieces that you might need in order to maintain and keep your system running. So yeah, the reason I'm saying 64-bit dual core is for the desktop environment, there is only 64-bit available. However, if you need a 32-bit, there is a minimal version that you can install that will give you that ability to have a 32-bit version as well. So you need at least 4 gig of memory, and I'm saying 48 gig of disk space on a desktop environment. And the reason for that is that you're going to want to cut your file system up into different partitions so that you can, reduce the likelihood of running out of disk, because you are creating all these generations for every change you make to the system. So, and those two take a small amount of disk space, but it will add up, it will add up. So depending upon how many of those you need to keep out there, you may need additional disk space even beyond 48 gig. It's hard to gauge unless you know how many generations you're going to want to keep. So I always have a tendency to make sure I have the drive space because it's much easier to have it up front than to expand it. So I guess the thing we need to do right now is just go ahead and do an installation of NixOS so you can kind of see how it is. Now, I'll tell you a couple things. First of all, if you're not comfortable with the command line, if you're expecting a GUI to help you install NixOS and make things easy for you to partition and set up your users and your networking, forget it. NixOS doesn't have a nice GUI. It uses the command line to do it. More importantly, it uses a configuration file to set it up. So if you're not comfortable with that kind of an environment, then NixOS probably isn't for you. But if you like tinkering around with systems and you don't mind getting down in the command line and you don't mind editing files, maybe you use Nano, maybe you use Vim, whatever, to do your editing, as long as you're comfortable in doing that, then it should go smoothly for you. But again, if this isn't something that you're comfortable with and trying to figure out what packages you need, because that's really the real core chore here to do is, remember, you are defining the end state of your system, so you have to think about all the packages that you're going to need in order to build up for that. So yeah, it takes a little bit of work to plan out your systems, but the one thing is you don't have to get it right. They have generations here that you can continue to tweak and add on additional features and functions that you might need over time, so without penalty. So let's go ahead and do that. To the download page, and you can find it by going to that tab. It'll show you. Now this is the package manager. We talked about that a little bit. You have to have an existing Linux distribution, or you can install it on a Mac, or you can install it on Windows that has WSL2 on it. You can also create a Docker image, you can verify, and so forth. So this is just going to put the package manager on an existing operating system that you have. This one is 2111, as you can see, and I have ISO images. I also have VirtualBox images and Amazon EC2 images too as well. There's the GNOME 64-bit. There's also one for Plasma 64-bit. I haven't tried that one. And then there's the minimal ISO down here for either 64 or 32-bit. So I just picked this one. So over here I have a couple of options here that I can do. So I can run the installer, I can run with no DOM set, I can run with copy to RAM, debug. If I was doing programming on this, I probably would do that, or use a serial console. But we're just going to go ahead and launch the installer. This system has 4 CPUs, 4 gig of memory, 64 gig of disk space. Because I'm going to set this up for, hopefully, I'm going to set this up for Linus, so which is my security tool. So I just hold on here, don't go. It'll eventually come up in GNOME. There you go. Okay, so I'm up. So the first thing, as you can see here, I'm a little cramped on space. Okay, so I'm in the live CD here. And I can go down here and it'll talk about, here's how to get it, here's how to boot it. And then we'll come into the partitioning step here. So there's the legacy. All I'm going to do is an MBR. I've had enough problems with Proxmox and UEFI, so I'm not going to try that today. Yeah, so you can use fdisk if you want. I'm going to go ahead and get to the root, or get into root, since everything here has to be root to do any of this. So the first thing, I'll run parted in order to set up the label on the system, and now we have to do this. Okay. All right, so I have my configuration set up here. So I'm going to have a separate var, a separate home, separate opt, and a separate temp. And I am going to, now I need to generate my configuration file for the first time. You do this once, and it specified that my root is now mount, so it knows to put it in mount etc. Oops. NixOS. Okay. All right. So now it's set that up. I should be able to go to there we go. And there's the two configuration files. So the hardware contains, you know, your drivers and all that stuff for what your devices are. And I'm going to use, I guess I should use Vim. You can use just about any editor for this, so it's not a big problem. So the first thing I want to do is, if you look down through here, these are the imports. These are defining, like the first thing is your grub loader. Well, the only thing I need to do is uncomment this one so that it puts it on my SDA device. I can set up my networking here. I'm not going to. I am going to set up my time zone. So let's go ahead and do that. I'll set it up for Chicago. I'll leave the DHCP alone for now. I'll probably come back in at some point and set that up for a static. All right, so I need to uncomment all of this. So I get my default encoding and my keyboard map. And then we'll come down here to X Windows. We have server enable true. That's all fine. And I'm not going to do anything with that. I could set up my printers. I could set up my audio. Okay, so let's go ahead and get a user defined. I'll have to come back into this. Make sure that you get the closing brace, otherwise you'll get an error. And I'll change my, oops, jumped on me. Okay, that should be good. And then here's my packages that I can install. So let's see. Yeah, we'll go ahead. Now remember, these are you're not running on this. There's this drive yet, so you need to tell it what you need. So I'm going to go ahead and do my usual. Those are the packages I want. Firefox. I don't know, I might want Thunderbird. Yeah, we'll go ahead and do that one too. And then down here, I can enable SSH, and we'll go ahead and do that. And then if I want to enable a firewall, that's here, and I can set up all the allowed ports and all that stuff. But I'm not going to right now. You can do this all later. You can wait on it. So, all right, we're done. So the next step is I need to do a build out on this. So the first time you do this, you just do a NixOS install. And if there are any errors at line 78, okay. Oh, yeah, I got to see. This is what happened. I did not get those on. Yeah, get that. You need that in order for it to work. So this time it should work okay. So it's good to show some errors, right? Because it might be something that you run into too. Okay, so it has stopped and has asked me for a root password. We'll go ahead and do that. Okay, so it's all done. Now I'm going to have to go fix some stuff here. So yeah, I had to. I'll go ahead and do a shutdown now. I need to go fix my boot order because otherwise it's going to just come back up on the. It's just going to come right back up on my CD-ROM, which I don't want. So let me fix that. So I'll put it under the hard drive so that it picks that first. And now I should be good to go. Now, one thing you'll notice here is there's two options. Now, NixOS default is what the latest configuration. Now, I only have one because this is the initial one that I built. So yeah, well, it doesn't really matter. I could just pick that one, and that's going to be the same. Okay, so I can't log in as dware because it didn't ask me for a password yet. But I can log in as root. And I can just go set a password on it. All right, and then we'll exit out of here. Okay, so the other, and now I can log in as dware. Now, DJWare, so that this, I need to get this under, yeah, I've had problems with Wayland under NixOS, so yeah, it doesn't always pick up my keyboard and my mouse correctly. It doesn't track correctly, doesn't, yeah. All right. No, I don't need the tour. Now, yeah, it is GNOME 41. So we're up, and this, let's see what we got. So yeah, I have Firefox, so we'll add that to my favorites. We're going to remove the GNOME from my favorites. We'll just go ahead and put this over here. And I put this over here. Line this up the way I want it. We'll add the favorites here. Let's get my display set up. Yep. Okay. Get rid of that stuff. Okay, let's see. So now I've got everything set up the way I kind of want it. Let's see, before we do too much here. 442 meg. Now I did run a few things, but let's go ahead and fix this. Change the colors. All right. So as you can see, it's not particularly taxed on the CPU. I have 80 tasks running, 203 threads. So yeah, let's take a look at the number of packets. Yeah, I guess we need to be in a terminal window, don't we? And I need to get there we go. I'm just setting up my configs so that I don't have my public IP address showing. Okay, so we have, as far as glances is concerned, 711 meg of memory, 3.84 gig available, and so forth. So yeah, You can see that the mounts, it did respect the way I wanted it set up. So I have 46% in my root directory available. That should give me enough places to, configure this out the way I want to. And then my var is over here with quite a bit of room for log files and AID, and all that stuff. Let's go over here to opt. Okay. All right, we'll run through this real quick and see what we get as a baseline. So let's just see what we get here. Looks like a score of 61. Let's just see. Okay, so we don't have any warnings, which is, they may have moved that firewall warning out of here and down into the suggestions. I'm looking for my drive configuration. Yeah, this is all needed to be hardened. Yeah, I need an issue. This is all standard stuff, nothing big deal. Yeah, so it's fine. It did not complain about the way my file systems are set up. So at least I don't see anything. Yeah, I don't see anything. So yeah, so 61 is the base. That's one of the lower ones, but again, it is struggling somewhat to find. You saw all these warnings in here. It's like, I don't know where to find that. Yeah, so yeah, it was kind of, NixOS is very different from what Linus would expect to see. So yeah, we'll have to harden it at some point and see how it goes. So I guess the other thing that we want to do here, let's go ahead, put this over here. Oop. There we go. And let's get our manual back up so we can do some other things here, so you can kind of get an idea of how it works. Okay, so it talks about the changing of the configuration here. So the next time you run this, let's go add something. First of all, you can use Nix search to have it look for something. Let's say I want GNOME tweaks. We'll see if we can find it. Okay, there it is right there. So you can ignore this part, but all of this you will need if you want to install that tool. So let's say I want to add that, and let's go to, yeah, I know somebody's going to say, well, that's been disabled in 4.1. Yeah, well, I know, but I'm just going to change the theme and sneak back out, and no one will notice, right? Well, need to be sudo. All right, let's go down to where my packages are. All right, so this time I want to do a sudo NixOS rebuild, and we'll say switch, so that it switches to the latest version, I believe is what that means. So it'll make it the default, make this one the default to boot from. Then we'll do an update and see if there's any packages updated. So again, we can come in here, and this is the configuration, the new one I just built, and that's the old one. So I can choose which one of those two I want to boot from. So I'll let it boot from the new one. And now I should have my tweak tool, hopefully. Yep, there it is. Yeah, I know. All I want to do is that. Okay, so I have that done now, and let's go back in here. I believe the command is just upgrade. There we go. It's looking for any updates. Okay. There's my update for configuration 3. Sometimes after you have done a reboot, Firefox does not work correctly. So we've done this. We've upgraded the OS. Now the next thing we want to do is we want to find out about how to clean up and do some garbage collection here. So let's see, there should be one in here about cleaning up. Yeah, there we go. So how to maintain this, because I now have 3 stores. I can do a Nix collect. It's just going to tell me what can be done. It's not going to actually, oops. Yeah, this might help to do it. It also might help to spell it right too. Okay. So it's going to tell me I have these stores that I can get rid of. Now, to get rid of them, okay, now it's deleting them. So the -D gets rid of them. It hasn't updated the grub menus, so okay. Now it should have. Yeah, now it's just one. Okay. Not a bug, just a loose nut on the keyboard. All right, so you know, you can, the nice thing about this system is that you can build things up slowly over time. You can keep it, maintain it updated. Your updates are going to be in a form that are isolated from one another. And they're also going to allow you to roll back to an earlier version in the event that you need to do that. So as far as the system is concerned, I mean, the package manager, for my taste, I mean, I realize there's 65,000 packages that it's looking at. So yeah, it's quite a few. It has actually more than Debian and more than Ubuntu does. Yeah, so let's go back and talk about some final thoughts here and wrap this up a bit. So yeah, so what are my final thoughts here on the system? So I have been using this for not very long, about a week, and just going through the manual and looking at how it's put together. Declarative systems are, I mean, it's nice to not have to put in all of the manager pieces that you normally would need in order to build this out. Now, if I wanted an exact duplicate of what I just did with the partition map and all that, I could copy out my configuration file, store it on another computer, build up everything, and repartition the hard drive. Of course, you still have to do that manually. But then once all that's done, put the config files back and then do an install, a NixOS install. And I would have a footprint that looked exactly like this one. So yeah, it's very nice. And then over time, it's going to keep things version control. It's going to keep things isolated. So hopefully, that the system will protect you from applications that are installing dependencies that overlap. In Windows, that's pretty famous for. Linux has that problem to some degree, but it isn't nearly as prevalent as it is in Windows. The proverbial DLL hell. I remember a loop that occurred when a particular update that a person did, and then an install of a package created an instance where you couldn't roll back to the last known snapshot, and he couldn't roll forward because it was broken. So yeah, he couldn't go back, couldn't go forward. So the only alternative he had was destroy it and start over with the installation. So all too often, that is the way to fix these kinds of problems, whether it is on Linux or is on, on Windows, or even on Mac. Mac has that propensity to have that happen as well. So what do I think of it? I think it's really too early for me to really say. I'd hate to give a judgment on it and say, oh, I think it's great, or I don't think it's great. I mean, I like what they're doing. I mean, I like the fact that we're talking about declarative systems now, and we're starting to get away from some of the imperative types of things that we have done, and the blunders that we have done in the past, so that we are trying to create our systems. Basically, you can think of it as constructing something out of Legos, is that we are able to gradually build up the systems the way we want it. We can plan them out to a certain degree, but as you know, things change over time, their needs change. Maybe you want to try some new things and you want to add those packages in. So yeah, what you start with today may not be what you end up with a couple of years from now. And I think NixOS probably would be able to handle that. It would be able to stay with you over those kinds of things. Now, can it install all the print drivers that you need? Can it install your audio cards? Those are always problems for Linux, particularly. Now, this kernel is 5.10, so it is a long-term support kernel, so it does not have all the bells and whistles that are in 5.12 and 5.15 and 5.18 now. So yeah, all those kinds of things that normally would be in Linux, you may be missing drivers on new hardware that is coming down the line because this is an older kernel. But keep in mind, they update this twice a year. So yeah, they stay on a release schedule twice a year. You can, if you want, you can change your pointers to your repos to be bleeding edge. So you can get the latest packages that are available to NixOS if you want to do that. That's basically going to turn you into a rolling release. And so, yeah, I don't think I'd want to do that for production systems, but you certainly could do that for a test system if you wanted to experiment with it. So there is instruction. I didn't go through everything. There is instructions in the manual on how to do some of those things. And yeah, I think that's where I'm going to leave things today, is right there. I hope you enjoyed this video today and looking at NixOS. I'll probably do some follow-up videos on it as I gain more experience with it. I don't have a full knowledge of the architecture. I was looking for architecture slides on how NixOS is actually put together. I would really appreciate if one of the project leads or one of the technical leads would at least jot down some notes, on how the thing is actually pieced together, what makes it, how are these various components hung together, and how does the various levels of protection that is in NixOS function. I'm sure it might be in the manual. I just haven't encountered it yet. I haven't read it all yet, so I'll admit to that. So I'll do my diligence first before saying anything along those lines. So I don't want you to think that I think there's things missing with NixOS. I just don't know at this point what it is I need. But I would like to see, the first thing I always like to look at in a distribution is show me the architecture. Show me, I'm an architect, so show me the architecture. That's the first thing I would want to see. Anyway, hope to see y'all again real soon. And please like and subscribe. Bye for now.